Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I think last lesson we stopped somewhere here in tissue engineering. So I hope you guys have explored the many applications in tissue engineering. There are so many others, not only limited to the one in these images, but there are so many others. Okay. Next, another field that can be under the biomedical engineering is also known as biomaterials. So biomaterials is very important field actually, mainly dealing with materials that can be used inside the human body. So for example, in medicine, restoring function, facilitating healing for people after injury or diseases. So they've been using natural synthetic for medical operation to support, enhance, or replace damaged tissue or biological function. So for example, if a person has a fractured bone, right? Fractured bone. So what they have to do is they will have to do a little operation in the part where he has this fracture, and then most probably they will try to put a plate or screws. So this plate or screws is made from materials like, for example, metals, stainless steels, titanium. So this material which is going inside the human body, it has to be biologically compatible. Therefore, you combine the bio properties with the materials. So bio properties combined with the materials, it become biomaterials. So mechanical engineer, they will do the design, right? Mechanical engineer, they will draw the design, test the materials which has, after the drawing they will manufacture or they will print out, they will machine the actual materials, and then they will do the testing, strength testing, corrosion testing, and what else, yield, strain, so many others. Not just that, also some tests on the biotribology. So the tribology of the materials will be investigated, so that the material, when it goes inside the human body, the human body will accept this material as part of the body system. Otherwise, if it is not compatible, it's going to reject this material. So when rejection happen, what will be the case is that potentially the other cells, surrounding cells within the screws and plates, it will not grow onto the implanted materials. So the materials will be attached on the bone, but the bone tissue will not grow on these metals. So what will happen then? They will start to have some sort of inflammation. From this inflammation, they will have some sort of rejections, and then from this rejection, what will happen is there's a complication in the materials matching with the tissue. Therefore, there will be swelling and other troubles, so that they will have to reoperate and remove the material. Therefore, the biomaterials engineers under the clinical engineers, they will do this all sorts of tests, and mainly they will try to replace the biological function of the damaged tissue, so that the materials that will be implanted inside the human body will have the same properties as the original tissues or the original damaged tissue. So modern field of biomaterials combine medicine, biology, physics, chemistry, and the more recently influence from tissue engineering, the topic we covered before, material science. Okay, and this field has grown significantly in the past decade. Okay, due to tissue engineering. Another part is regenerative medicine. So this is a great focus field as well nowadays, and more. So what is this figure actually? So there is a inside the blood vessels. So inside the blood vessel there is a what we call clogging of let's say the fatty tissues inside the blood vessels. So they will put this what we call like angioplasties or the balloon, so that it will be inflated inside, so that the spaces that were before it was small, it is now grown bigger. But and then they will remove this balloon. So they will remove this balloon, but the things what we call the stent will stay there. This like network what we call strings, it will stay there. So the balloon will be removed and it will stay there. But these materials that they use inside, it has to be compatible and also has what we call a good strength. I mean long-lasting materials. That means it's not going to rupture or it's going to cause some sort of other troubles during 1 to 2 years of usage, right? So potentially it's going to stay there forever for this operation, right? This is potentially one of the application. Next, okay, we are still on the biomaterials, right? These are the general, what we call the general functions, what we call the areas of focus that biomaterials plays roles in biology, chemistry, engineering combination, and then you have this tissue engineering, and also it can goes up to drug delivery. So I have listed here few application that is focused in the biomaterials nowadays. Actually there's so many here application. Right, there are so many application listed here. So for example, we can use these biomaterials system or technologies nowadays in the joint replacement, bone plates, and intraocular lenses for eye surgery, something to do inside the eye. Bone cement, I mean when there is a fracture or missing of the small portion of the bone, and the replacement of bone materials, so you can use bone cement. Artificial ligaments and tendons, dental implants, tooth fixation, blood vessel prosthesis, heart valves. So people can nowadays replace heart valves. Sometimes people have medical conditions such as the heart valve become damaged or ruptured, let's say. What we call the valve is not functioning as before, so in original condition. So you can replace these heart valves with biomaterial, skin repair devices, artificial tissue. For example, people involved in fire burn and so on, so you can replace them with the skin repair. So you have a layer of skin patch on the area of damaged part, so that the skin will grow nicely. Cochlear replacement, people who have problems with hearing inside the ear, so you can replace the main cochlea. Contact lenses. So how do we understand contact lenses is a biomaterial? So just try to ask this question. What do you think? Right, contact lenses. So the engineers or the biomedical engineers, clinical engineers, they already researched on these materials and part, so that how can we produce a contact lens? That means the lens which can stay inside on top of the surface of the human eye. So you need a very flexible material, at the same time have a great strength, so that it's not going to break easily. So it is soft and it's going to stay, and it will not cause any sort of irritation in the human eye, those who are using it. Apart from that, it also has the optical function, like it's going to improve the views and so on. So uh, you as an engineer, you have to think in such a way that all these points is considered. I mean, in the design, you have to make the material which is flexible, so it is soft. It can go inside the human eye, and you can place it on the top surface, and then it is compatible in the human eye. Is compatible, so, and you can use it for long-term purposes. And then what else about the contact lens? Is a material with the specific optical properties, so that you can see through the contact lenses. And sometimes people wear the contact lenses for just for the sake of building their confidence, like to make it look better, their eyes look better. So that's also a function. So you have to look at the cosmetic point of view for designing these contact lenses. And then there's also this breast implants, drug delivery mechanism, sustainable materials, the materials that can be used again and again, or what kind of material is suitable for the biomaterials properties. Vascular grafts, stents is the one that people who has heart problems, the blockage in the blood vessels, so they'll put these stents. Nerve conduits, surgical sutures, clips, staples for wound closure. So nowadays, when they do the operation, they no longer do the stitching part. So what they do, they just staples the wound side. So potentially the wound will close in a few days, and then the staples will be removed. Pins and screws for fractures, stabilizations, and last but not least, surgical mesh. Right. That's already we have covered the biomaterials definition. Now we go on to clinical engineering. This is a specialty area within biomedical engineering, responsible primarily for implementing medical technology to optimize healthcare delivery. So your focus will be in healthcare delivery, in the hospitals, in the places like where laboratory is being used, and so many others. Roles of clinical engineers include training, supervising biomedical equipment technicians, working with governmental regulators, hospitals, inspection, audits, serving as technological consultant for other hospital staff. That means you will be the person in between machine and man. So whenever you have to brief the doctors on the usage of specific machines and materials, so you are the person who will come in between, and who will advise the medical personnel, hospital staff, such as nurse, doctors, and others. Let's see some of the application of knowledge. Where do this clinical engineer will be? Tasks during operation, for example, if you are involved in the operation theater, the units, so you will have to be you will have to make sure the running of apparatus efficiently and safely. That means you are the one who will be responsible to go in and check, so that everything is working, functioning, so that the operation will be successful. And then tasks as medical examination personnel, running the examination machine efficiently in locating the disease. That means you are up to certain level, you also will pinpoint the areas that been imaged, for example, or the examination has is been done. Sometimes you also will be involved in the intensive care unit, right? Intensive care unit where the medical workplace keep the life supporting equipment, right? So you are the one who will make sure that the life supporting equipment is safe and everything is functioning A to Z. I mean, in very good condition, safely, and it can be used. So, as you know, intensive care unit is the cases where mainly for the critical cases. So you will be the person in charge to look after the machines and systems that assisting the people with their life supporting devices. Right, that's on clinical engineering. Next, we move on to bioinstrumentation. So, bioinstrumentation is where you combine the instrumentation properties, knowledge, technology onto bio activities, right? For example, in this, if you can look at the image that I provided here, so the labeling, the colors, and there is a legend, pelvis, thigh, shank, foot, and then here they have this posterior, anterior, and all these labelings, front view, side view, and then down below there is sensor attachment positions. You can see these are the sensors equipped or attached onto the human body. So this is a very interesting field, and it is most what we call suitable and recommended field for the students who graduate under medical electronic engineering, because you will deal with the high tech and then mainly on instrumentation to do cutting edge research, and then you will be involved in the designing and positioning, what we call design and positioning of the sensors that will be used to identify signals from the human body. So bioinstrumentation is known as it's a very important field. So nowadays people do have you if you have heard about drowsy detection machines and system. So for example, in the cars, now the expensive cars, they have system that will be able to tell whether the driver is in the alert position, or they are quite close, or they are entering the non-active zone. I mean, they are falling asleep or so on. This is designed through the bioinstrumentation. For example, they have sensors capturing the eye movement, the opening and closing of the eyes, and then the grip on the hand of on the steering of the car. At the same time, there are also some system cameras being used to detect the facial impression. So contoh macam detect muka, keseluruhan muka. So if the person driving, if they yawn, maknanya dia menguap, the camera will capture, and then they will collect the data from the eye recording and also the grip on the steering wheels. So when the grip become less and less stronger or weak grip, and then the eyes is becoming what we call the pupil is dilated, and then it is closing, becoming very small, and then combined with the yawning signals, so you will be able to provide an alert sign to the driver, or so that they wake up again. So this is done through bioinstrumentation. That's just one of the examples. So most of the research are involved in the laboratories, and some people, they love to do this designing part, instrumentation part. So this is the potentially one field that will be interest for the student, I guess. Right. Another example is you can see body motion detection system. So this guy has been fixed with the head motion posture sensor, so it will detect the eyes trunk motion, and then arm motion. So they put the sensors in the arm area, hand grasp sensor, gloves, checking the bending of the fingers, hand movements, and then total weight 2.5 kg battery driven. That means the system is being used with the specific weight and so on. But nowadays there are more advanced research. They are placing these sensors as a wireless position. Even the ECGs, EEGs, they are using mainly the wireless type of sensors on human body, because wired based sometimes do cause trouble in many measurement. So next is physiological parameters. For example, the same machine, you add on some more sensors, such as sensors which can detect the heart rate, respiration, so respirometer. So you will be able to get this brain wave, body temperature, blood pressure, muscle tension, perspiration, monitoring system. So how much a person perspirated during the test, and then pulse wave, digital plethysmography. So you'll be able to tell the pulse reading, the oxygen, and so on. So that's another good example of bioinstrumentation, right? Moving on, another part is important as a biomedical engineers, so that we are involved with the body or the firm, and also involving with the societies. For example, the one I show in this slide is Biomedical Engineering Societies, BMES, in the bioengineering field. Biomedical engineering, it's a professional society founded in 1968. Society now boasts over 7,000 members and growing. So until today they have this Biomedical Engineering Society. Then in Malaysia, Biomedical Engineering Association Malaysia was established in 23rd of March 2001. It was timely. It was introduced quite close to the time where the biomedical equipment maintenance and clinical practices of in Malaysia. So BEAM is called BEAM. This is a society in Malaysia. Okay. You have to involve in this society, so that you know who are in this field. You know, you can build your network. You can build your connection with other biomedical engineers, clinical engineers, bioengineers, so that it is easier for you to move around. That means once you have connection, you can do collaborative work, networking, and sometimes maybe you will not stay in one place, you will move to another job. So by involving in this society, you will get to know people. Otherwise, you will just be working in the fields, and without networking, it's sometimes difficult to move. Okay, next point that I think is quite important to cover, because since biomedical engineering application, this subject is the one of the last subjects that you will be involved before you graduate. So we do also want to cover a little bit on the career preparation. I mean, any engineers, biomedical engineers or electronic engineers or any engineers. So first and foremost, we have to be a good engineers, obviously. Beyond this, what we said, you need to have a very sound understanding, and you have to work on the life science system, and also the terminologies that we use. So I always told my student that you need to sit down and learn so many of the medical terminologies that you will not be afraid once you join the biomedical engineering field. Okay. um, and like other fields as well, you are required to have a good communication skill. This is very important. If you can communicate well, if you can have a good communication skills, that means that's an extra point, because the biomedical engineer provides link among professionals with medical, technical, and other backgrounds. So you will be the interperson with between the medical personnel, so that the professionals, people who selling the equipments, the users, the doctors, the nurse, the technical people, so that you have to have a very excellent, I would say, an excellent communication skills, so that people can understand you. From our experience, we have seen top quality biomedical engineer must have excellent knowledge of physiology. See, I told you earlier. So, like in our course, that we also have introduced our graduates to physiology subject, and also some physiological signal measurement and system. So these two subjects is really important, so that you can make a sound judgment in solving biomedical problems. So after this, when you start to work, people will try to explain some terms on physiology and physiological measurement. So you will be able to, what we call, join in the same discussion, so that you can also play a roles and part as a biomedical engineer. So we don't want you to be stay outside the circle, so that when people are talking about physiology, you start to think what is the point they are talking, what is the thing they are discussing now, I don't understand. No, we already equip you with these 2-3 subjects actually, so that you are ready for this career path. And then when working this specific area, so you also need to have knowledge on how disease alters function. This is the field of pathophysiology. So you need to know about pathology, right? And then how the certain few disease, and then how this disease is being addressed with a particular system, machine, and others. So you have to be ready with this knowledge as well. What else? So when you are personally equipped with the pathophysiology physiology knowledge, and biomedicine knowledge, physiology knowledge, so you don't have to rely on others. You will be able to sustain yourself in that position, right? And then, okay, we have covered this. You have to be hardworking. So in any job, so hardworking is what they say nowadays. So once you are hired, you have to show to the employer that you are the one, the right person they have chosen. So because you are willing to work in many situation and condition without giving much excuses, and then you understand life sciences, good communications, physiology knowledge, and also another important point is the innovative. You are able to present ideas such as design, or what other methods, techniques to be used in the field, right? So innovative is another part, but we will also try to equip the student in this subject. One is to know few system, at least few important system, and then which system is being used for which diseases. That's what we aim. Another part is you will be able also you will be also exposed to the innovative design projects, so that you able to uh, design your own biomedical sensor system. So you will come up with your own drawing and design, so that you can present this is the idea. So potentially when you join a company institution, so your boss will he or she, they will give you this task, like one particular problem. So how do you as an engineer solve this problem through innovative ideas? So that's what we want you as an engineer to have ideas you can propose to the boss, to the companies, to your employer, that these are the potential solution A, B, C, D, 4 solutions. So if you can do that, that would be really interesting. Right, like other field, for the clinical biomedical engineers, you have a very what we call vast coverage of job application that it can be done. For example, in the hospital, so you can become medical equipment supervisors and advisors, or if you work in a research institution, so you will be a researcher in biomedical engineering field, or you will be continuously doing some research. Then companies, biomedical equipment development, quality checks. So these are another options. Or you can become a technical advisor. Technical advisor, so you become a marketing technical advisor for companies, right? So this is more to do on the technical part of the management perspective. So you will be holding an important position. Mainly will be designing. Mainly will be explaining to the people on the technicality of each machines, systems, for so that the companies understand. So you become like an advisor in this job. Right, and then I'm sure you guys have heard this quite a few years back. It's already been introduced that this is one of the acts that is required by the ministry for all the medical equipment operators. I mean, before this, even electronic engineers, they can operate medical machine, but nowadays they want to have a certain qualification for the people who handles the medical equipment. So under this Medical Device Act 2012, Act 737 requires medical device to be registered under the Act before it can be imported, exported, placed in the market. For that purpose, you have to register the medical device according to the requirement under the Act of 737, which is declared by the Authority in Medical Device Regulation 2012. Right. This one you can check online. You can search for Medical Device Act. You will see so many important notes and points will pop up in the through online. So this is one of the ethics and codes that they're trying to introduce since 2012, right? Which is good, so that the workers, the people who handles this machine, they know what are the safeties and standards that they have to follow through this Act 737. Right. So this is the continuation slides from the previous one. Basically, this is the objective, scope, and for the ethics codes for biomedical engineers. Guidelines developed to provide information, explanation on how to register medical device under Act 737. So they have the specific system, MEDC, scope of guidelines. Guidelines covers all medical device to be registered under Act 737. So this is just the scope. And then what as a medical device? The term medical device covers any product used in healthcare for diagnosis, prevention, monitoring, treatment of illness or handicap, but it doesn't include the drugs. Drugs tak termasuk. So these are the points covered for the biomedical engineering ethic codes. Right. Now we have come to the group assignment. Right. A group assignment. From the specialty area discussed earlier, students are required to identify particular system or device. That means you can select anything to do such as system or device in biomedical engineering application, right, which falls under this group and category, the one that we have discussed so far in the lecture. So understand the system. So if you have chosen the device or system, understand the system and the overall application. So we want to go find out, if we choose a device, what is the device, how it will be used, so what is the function of the device, and for example, it is used on such a device, such diseases. So to cover which diseases, the device that you select, it is used for which kind of is it monitoring, diagnosis, or what other focus of disease. Okay. But if you can show the device, which is the main point is the latest technology. So don't choose something which is very old, right? So that's why I highlight here. So you choose something that to do with the latest technology. By now you know already so many instrumentation in medical instrumentation, biomedical engineering system. So I would like you to select one particular device or system, and then you explore them. So from this, you will have to do your own slides for presentations. You'll do your own short report. So the report will be around 5 to 10 pages only. 5 to 10 pages only. So not longer than that. And then you will do your group assignment submission, right? So from the titles or idea given. So I would like you to choose the title first, and then refer back to me. That means you refer back to me whether the title is okay or not. If I agree, then you proceed with the assignment. If not, then you have to find out a different title. So I think that's all for this week. So time given for you to do this assignment is just 1 week. So you will have to complete by next week, 1 week from now. So not much time, but 1 week I think is enough to do 5 to 10 pages of assignment. So last but not least, thank you very much. See you in the next lesson. Group, I will let you know. I will inform you who belongs to which group. So I will share this information in our group discussion. Assalamualaikum warahmatullahi wabarakatuh.